everyone! Today we're going to start Chapter 10, which is on probability. Today's lesson is on 10.1, which are sample spaces and probabilities, so just some basics of probability. We're starting at the top of page 283 in your journal, and it defines the sample space of an experiment is the set of all possible outcomes for that experiment. So we're going to go over your explorations, which would be some examples, but a quick example would be if I tossed a coin, my sample space is either heads or tails because that's what my outcomes could be. So let's look over some of your explorations. On exploration 1, it asks, in the experiment, we have 3 coins that are going to be flipped. List the possible outcomes in the sample space. So what is every possibility you can get from flipping 3 coins? So we have to just look at it kind of methodically. Like the first coin could be a heads, the second coin could be a heads, and the third coin could be a heads. Or you could have heads, heads, and tails. Or you could have heads, tails, and heads. Or heads, tails, and tails. Or we could have tails, tails, and tails, or tails, tails, and heads, or tails, heads, and tails, or tails, heads, and heads. So there are 8 possibilities here of what we could toss if we were tossing 3 coins. All of this together, all of this is called the sample space. It's all the possibilities. So what about if we're rolling a die? So if you are just rolling one die, then you have 6 possibilities. You could either land on a 1, a 2, a 3, a 4, a 5, or a 6. There are 6 things in that sample space. But what about if we're rolling 2 die? The first die could be a 1, and the second die could be a 1. I'm going to write it like that. So it could be 1, 1, or you could have a 1, 2, or a 1, 3, a 1, 4, a 1, 5, or 1, 6. Or what if the first one is a 2? You could have a 2, 1, a 2, 2, a 2, 3, a 2, 4, a 2, 5, a 2, 6. On, and you'd have 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. And to keep in mind, 1, 2, and 2, 1 are 2 different outcomes because the 1 is on one dice in particular and the 2 is on the other dice. So the second one should have how many outcomes? You think you could count them all? Probably has 36 totally different outcomes that you could have because you have 6 on the first dice and 6 on the second dice. Let's jump to exploration 4. So here we have a bag of marbles. It has 2 blue, 5 and 5 red. And we're going to draw 2 marbles from the bag. Now look and see that the marbles are numbered. So you have blue 1, this is blue 1, and blue 2, red 1, 2, 3, 4, and 5. All right, so first it says, how many ways can you choose 2 blue marbles? How many ways can you choose a red and a blue, or a blue and a red, or 2 red? So how many ways can I choose 2 blue marbles? Well, I could pick out blue 1 first and then blue 2, or I could pick out blue 2 first and then blue 1. So there are 2 ways to choose 2 blue marbles. What about a red and then a blue? Well, I could pick red 1 and then blue 1, or red 1 and then blue 2. So there's 2 ways there. But I could pick out red 2 and then blue 1, or red 2 and then blue 2. So there's 2 more. Or I could pick out red 3 and blue 1, and red 3 and blue 2. So there's 2 more. And then we're going to have 2 more here and 2 more here. So we had 2 5 times. So that should make a total. There's 10 ways that we could pick out a red 1 and then a blue 1. So what about a blue 1 and then a red 1? You could pick out blue 1 and then red 1, or blue 1 and red 2, and blue 1 and red 3, and blue 1 and red 4. So there's 5 ways you could pick out blue 1 first and then a red 1. There's also 5 ways to pick out blue 2 first and then a red 1. So that would be 10 more ways. So there's 10 ways to do a blue and then a red. And what about 2 red? So you could pick out red 1 and then red 2, or red 1 and then red 3, red 1, red 4, red 1, red 5. There's 4 ways there. What if you started with red 2? You could pick 1, 3, 4, or 5. There's 4 more ways. Red 3 has 4 ways. Red 4 has 4 ways, and red 5 first has 4 ways. So you had 4 ways times 5 for a grand total of there are 20 ways you could pick out 2 red marbles, depending on which one you picked first and which one you picked second. Now the sample space here is pretty large. Well, in fact, if we go down to see what's the total number in their sample space, if we add all of these together up here, there's going to be 42 in our sample space. And to write it out, you really have to say like blue 1, blue 2, and then blue 1, red 1, and blue 1, red 2, and blue 1, red 3. And there are 42 things that you would actually be writing out there. Up next, we have some vocab for you to write down. Feel free to pause the video if you just want to write and not listen at the same time. First up, we have a probability experiment, and it's an action or trial. It can be like tossing a coin or rolling a dice, spinning a spinner, okay? It has some kind of outcome that you're going to have. The outcome is a result of a probability experiment from the first definition there, okay? The outcome is what you get, that I landed on heads or 6, or I pulled the blue marble out of the bag. That's my outcome. An event is a collection of outcomes. So I can maybe say, what's the event of me rolling an odd number? And the sample space is all the possibilities. And the sample space can be quite large because you really have to list every possibility. So if we jump over to the extra practice on page 286 and look at number 1 and the directions, find the number of possible outcomes in each sample space and then list the possible outcomes. So what is every single possible thing that we could get? So it says a stack of cards contains the 13 clubs from a standard deck. So remember, a deck starts at 2, goes to 10, and has a joker, a queen, and a king. So those are your and an ace. Sorry. So those are your 13 clubs. And you're going to pick a card, and then you're going to flip 2 coins. So if we just kind of start looking at what that looks like, you could pick the 2 and you could get a heads and a heads. Or you could pick a 2 and get a heads and a tails. Or a 2 and get a tails and a heads, and a 2 and get a tails and a tails. Well, then what if you picked the 3 and got a heads and a heads, or the 3 and got a heads and a tails, or 3 and got a tails and a heads, or 3 and got a tails and a tails? And you're going to keep that up. You could pick the 4 first, or the 5 first, or the 6, all the way out to the ace. So there are 13 of these columns because there's 13 cards, and each column has 4 in it. So how many total things are in the sample space? There are 52 different things that you could get there. And on like a homework assignment, I would expect to see all 52 of those listed there, but we're not going to list them here. So below that, you spin a spinner that has the numbers 1 through 5, and you roll a die. Okay, well, let's look at those. So the spinner could land on 1, 2, 3, 4, or 5, but then your dice can land on 1, 2, 3, 4, 5, or 6. So you're really looking, I could get a 1, 1, a 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. On all of these, here I'll do a little more, like a branching method would be a little easier to write them out. So each one of these from the spinner can go to 6 options for the dice. And so how many options do we have? 6 times 5. There would be 30 in that sample space. Going back to your definitions, we're talking about the probability of an event. The probability is a measure of the likelihood or the chance that an event will occur. There's a couple of ways to write a probability. You can write it as a fraction. So here across the top we have it as a fraction. You can write it as a decimal, or you can write it as a percent. Either way, it goes from 0, which is impossible, to 1 or 100%, which is just certain it's going to happen. Like what's the probability you'll have homework on a day you have math class? 100%. There are 2 types of probability that we're going to talk about, and the first one is theoretical. So theoretical is in theory what should happen. To find your theoretical probability, you do the number of favorable outcomes over the number of total outcomes. So a lot of times you will see me shorthand that. I will just say favorable over total. Theoretically, if I roll a dice, I have a 1 in 6 chance of landing on any of those numbers. If I toss a coin, I have a 1 in 2 chance of landing on heads or tails. So if I tossed a coin 50 times, I theoretically should land on heads 25 times and tails 25 times. Theoretically, that is not always what happens. But favorable, I want to touch on this here real quick. Favorable is what you're trying for. So maybe favorable is, what's the probability I'm not going to land on a 5? So then everything but 5 becomes favorable. There's also experimental probability, and it is based on the repeated trials of a probability experiment. So if I tossed a coin 50 times, I might not land on heads 25 times. I might land on heads 30 times or 40 times or 1 time. Okay, that is your experimental. Number of successes over number of trials. And a success is just what you're after. So if I'm trying to land on heads, then that's what a success is measured as. Let's look at number 4 under extra practice. So it says at a school dance, the parents sell pizza slices. The table shows the number of pizza slices that are available. A student chooses a slice at random. What's the probability the student chooses thin crust pepperoni? So probability, favorable over total. So you're going to have to know total. So how many pieces of pizza do we have? So if we add up here, looks like we're going to have 42 pieces of pepperoni, and we're going to have 48 pieces of cheese. So we have 90 total pieces of pizza. And we want probability of thin crust pepperoni, which looks to be right here. So your probability is going to be favorable over total. And you can write it as a fraction and then always reduce your fractions. So we are looking at 17 over 45. All right, one of the last things we're going to kind of hit on is the complement of an event. So sometimes I want the probability of me not landing on heads or me not landing on a 5, and that's called the complement. So this bar on top, this would be called like a bar, but what this means is the probability of it not happening. Probability of it not happening. And to find that, the probability of it not happening, you're going to take 100%, this is 100%, minus the probability of it happening. And what you're left then with is the probability of it not happening. So let's say the chance of rain today is 40%. So the chance it's not going to rain today, I would do 100% minus 40%, and there's a 60% chance it's not going to rain today. So it's just the probability of it not happening. So this example is not in your journal, but I had a picture to go with it, so it'd be easier to explain via video. So here we have in the picture, this is all 36 ways you can roll 2 dice. So let's say the first dice was white and the second dice was red. Here's all of your possible outcomes you can get on the 2 dice. So this wants to know the probability that the sum is greater than 8. So we would just come in here and look for where is the sum greater than 8. So nowhere in the first one because it only goes up to 7. So there's 7, there's 8, but that's not greater than 8. So then here's 8. Let's see. So here would be greater than 8. And then you should kind of be able to find a pattern. Like all of those there have a sum that's greater than 8. So then we can just tally them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 possibilities of greater than 8 out of 36 total, which would be a 5 out of 18 probability that you're going to get a sum greater than 8. So up next, let's look at a sum that's not 2. Well, maybe you're like, I don't want to add up all those numbers that's not 2. It would be way easier if we would just add up the numbers that are 2. So if we add up what is 2, it's just this one right here. So there is a 1 out of 36 chance that it is 2. So we're going to do 1 minus 1 out of 36, which would be a 35 out of 36 chance it's not 2. And that's how the complement works. All right, one last one about the difference kind of between theoretical and experimental. So we have a spinner that's numbered 1 through 12. Each section in the spinner has the same area, which means you're equally likely to land on any of the spaces. And you're going to spin this spinner 180 times. Okay, it says so like you landed on 1 13 times. You landed on 2 21 times. You landed on 3 22 times. So if we add all these up, they should make 180 because you spun the spinner 180 times. For which number is the theoretical probability of stopping on that number the same as your theoretical? So if we look at that, theoretically, you should have landed on every number 1/12 of the time. Well, what is a 12th of 180? Using my calculator, a 12th of 180 gives me 15, and so which one did I land on 15 times? And that would be 9. So that one has the same experimental as it did theoretical. All right, let me know if you have any further questions. Thanks for listening today.